Okay, so welcome back, everybody. This lecture will deal with Chapter 2, Doing Social Psychological Research. So this is, again, an introductory course, and each chapter is essentially an introduction to various topics. That's no exception for this chapter. Chapter is not going to replace your research methods courses, of course. But I think it's important for us to have an understanding of where all this information and all these theories that we're going to be talking about throughout the semester, where they came from. And they come from psychological research, social psychological research to be exact. So it's important that we have an understanding of how that process works, so we can better critique the material that we'll be learning. Right? So why should we learn research methods? Well, you become a better, more sophisticated consumer of information once you have an idea of how scientific data, how scientific findings are discovered. Right? So learning research methods, you'll be in a much better position to critique certain studies, to critique the methodology, the analyses that were used, or to critique various theories as lacking, say, scientific or experimental types of support. So beresearch methods will certainly help you become a better consumer of information, a better skeptic, make you better at critiquing, let's say, various information, and including scientific information. Also, you can improve your reasoning about real-life events and problems. Some of the topics that we'll be talking about in this lecture deal with reliability and validity, and the importance of testability, and the importance of replicability, right? So those things are, of course, very important to science and to the kind of research that we do as psychologists and behavioral scientists. But those things also apply to just arguments that you might have in everyday type of life, everyday conversations. Also, learning research methods may help you perform better on these tests for this class, but tests in general, and it could also be helpful for you in future classes. Pretty much every psychology class, at least the survey courses, the 200 level classes that you're going to take as an undergrad here at SUNY Oneonta, include some component that deals with research methods. So I would not be at all surprised if you haven't already heard most, if not all, of this stuff before. And that's okay, because research methods and statistics in particular, which we won't get into too much during this lecture or for this class, but these are all tools, and you learn how to use tools by actually using them. So hearing this information multiple times is certainly a good thing. It'll help it stick a little better, right? So when it comes to the research method, how do we even begin? Let's say you're going to do an independent study as an undergrad, or a master's thesis as a graduate student, or a dissertation, a doctorate dissertation. How the hell, what should I study? Where do people get these ideas for these types of studies? Well, developing ideas can happen from a lot of different sources, or from a lot of different techniques. First and foremost, I think, is just being a curious person, asking lots of questions, right? And ultimately, you'll stumble upon a question that there's no clear answer to, or maybe there's a lot of answers to them. And you're like, well, which answer is right? Maybe there's no right answer, but maybe there's a better answer, right? So maybe you have a different answer. Maybe you have something to contribute to that question. So we start by asking lots of questions. But as it turns out, pretty much if you've had that question, chances are somebody else has had that question before, and chances are they looked into it, they tested it, probably even published it somewhere in the scientific literature. So the next step would be to search the literature. And when we say search the literature, we're talking about the scientific literature, which means mostly peer-reviewed journal articles, but also unpublished dissertations and unpublished manuscripts, all of those things. A good place to start, though, is actually with textbooks. Textbooks are kind of neat in the sense that they kind of do a literature review for you, right? If you have a question about why do people conform all the time, right? Well, we got a whole chapter on that. Go ahead and read that first, right? Maybe that'll answer all your questions. Maybe you still got more questions outside of that textbook, though. At that point, you might want to start Googling some questions, right? And you might say, what? Professor is telling me that I should use Google? Yeah, if you know how to evaluate the sources, the results that you're going to get back from Google, of course, right? And, we'll talk a little bit about what makes for a good source, what doesn't make for a good source, but that's information that you'll learn in your method sequence, 221 and 222. But when we talk about internet databases, we're talking about not necessarily Google, but more along the lines of Psych info or Psych articles. These are search engines of sorts. These are databases, but they're not going to pull up websites. They're going to pull up published articles and even books. And a lot of the time, more and more so, these databases include full texts of these articles. So once in a while, very rare, that you'll get a full text book available, but you can usually find enough full text articles that are available to you in Psych info or Psych articles, or some of the other social behavioral sciences databases that exist through the library. That will be, let's say, an additional step in trying to answer your question. Sometimes it just ends there. You got your answer. Somebody has looked into that question before and they nailed it. Chances are, though, that you probably still have something of interest to add to that area. Maybe you notice, all these articles seem to be glossing over or not even mentioning this part of the question. Or maybe these articles are answering the question or trying to answer the question, but the findings are totally the opposite of one another. So how do we make sense of that? Or maybe you notice, like, everyone seems to be going about this question in the wrong way. So those are all opportunities for us to do our own research and have our own research findings published. So one distinction that we need to make right from the get-go here is that between a hypothesis and a theory. In just common parlance, common conversation, people will tend to use these terms interchangeably, and people don't really seem to understand what a theory really is, right? We hear people all the time say, well, that's just a theory. And anybody who really understood what a theory is would never say such a thing. You would never say that's just a theory, right? Theories have enormous amounts of evidence behind them, evidence to support them. But let's take a look at each of these individually, and we can highlight some of the differences here. So a hypothesis is an explicit, testable prediction about the conditions under which an event will occur. That's a fancy way of saying that this is a testable prediction of what I think is going to happen when I manipulate this variable. I think this is going to happen. And hypotheses aren't an educated guess. We often hear that thrown around as a definition for a hypothesis. Not an educated guess. I would say it's an informed, testable prediction. This is what I think is going to happen. And I think this way because I just did a whole bunch of research on this topic, and I spent hours and hours going through how other people have approached this issue, what other people have found regarding this study that I'm going to do, this relationship that I am interested in studying, and I am basing my prediction on the results of prior scientific research, right? So hypotheses are informed. They're not always informed by prior research. Sometimes they're informed by theory. But let's say the best hypotheses, I'll be a little biased here, the best ones are going to be informed by prior research findings. So again, they could be based on observation, right? So it's a testable prediction based on what you just see every single day, or what you see in terms of trends in the stock market or trends in public health figures or whatever it might be, some type of observation, or that might be based on existing theories, and again, on previous research findings. So hypotheses you can test. And they're essentially what you think is going to happen based on the results of prior studies, theory, or observations. A theory, on the other hand, is an organized set of principles that is used to explain observed phenomena. In other words, theory is our best explanation for the facts that are in front of us. Key word in there, facts that are in front of us. So I teach psych and law, and I have a law background. So I will often use the analogy of a courtroom, right? A trial. So let's say you're a lawyer for the defense or the prosecution in a homicide case. Well, we know for a fact someone is dead, right? We know for a fact they were shot. In fact, we have the gun right here. It's in evidence. We have the gun. There's fingerprints on the gun. We have DNA evidence. We have eyewitness testimony. We have all of this evidence. Someone definitely died. Who did it, right? Okay, well, the prosecution's gonna have a theory of who did it, right? They're gonna have a theory of how this crime took place and why it took place, right? And who was involved and all that. And yeah, there could be a competing theory. The defense, right? The defense is gonna have a very different theory. Hopefully, right? If you have a decent lawyer, they're going to say, no, we could explain all of these facts, even though it looks really bad for my client, right? We have another explanation for all of these facts. So a theory is essentially, I don't want to say essentially, you can think of it in the same way. It's how do we explain these facts that are in front of us, right? So global warming is a fact. It's happening, right? Now, there are different theories as to why it's happening. But for someone to deny global warming, you're denying reality. That's just the way it is. Not to insult anybody, that's just truth, right? So one theory of global warming is that humans are causing it through increased CO2 emissions. And the vast majority of scientists who are experts in this area agree with that. And by vast majority, I'm talking about 97%, right? So that's beyond a reasonable doubt. That's beyond statistical significance. But then there's a handful of other theories out there that, nope, this is just this change, this climate change that we're seeing is just part of every couple tens of thousands of years or hundreds of thousands of years, the Earth just goes through these different cycles. And another theory I saw out there is, well, the Earth is slowly, shifting in terms of its tilt on its axis, so on and so forth. Okay, well, clearly some theories are going to be better at explaining the facts than others, right? And that's why sometimes, the prosecution will easily win a case because they just presented these facts in a much more thorough, much more convincing way than the defense. The defense's theory wasn't that great. So ideally, theories will be effective and precise at explaining the evidence that's in front of us. They'll encompass all relevant information. They'll explain all the relevant stuff that's in front of us, and lead to new hypotheses. You should be able to test a theory, right? Now, sometimes it could be really difficult, like, say, climate change, right? That's difficult to test, let's say, in a holistic way. You can test it easily in laboratories or different segments of it in a laboratory and in the field, right? We can perform experiments to support the tenets of these theories. So a good theory, you should be able to test it. It should generate new testable predictions that we could go out and try. And that doesn't mean you and I could go out and try, but people who have the means to do so, the expertise, the equipment, the money, so on and so forth. It should generate or lead to further research and a better understanding. So theories should be generative. Theories, you shouldn't just say, okay, that's the theory, end story, explains everything. Nope. Theories should constantly be producing testable hypotheses, new research, and through that new research, we should have an increased and better understanding of the facts that are in front of us. Okay. We might go through a couple of these, like just some definitions that we should get out of the way before we get into the meat of the lecture here. We could also distinguish between what is known as basic research and applied research. So basic research is done, let's say, for the sake of knowing, only for the sake of knowing. You might say, well, isn't all research like done because you want to know something? Yeah, definitely. But basic research, the goal is to just have a better understanding, in our case, of human behavior. We're not trying to solve any problem. We're not trying to fix anything about humans. All we're trying to do is understand them. So basic research is often used to test hypotheses that come from a particular theory. So basic research, I'm trying to think in terms, I mean, all of our research in psychology is inherently basic in nature because we're trying to understand human behavior, but psychology is such an applied science. Here's a good one that might make more sense in terms of making this distinction. So the research that NASA does, it gets criticized a lot because NASA is it's a multi-billion-dollar government agency, and there are people who will say, why are we spending all this money to learn about stars like that are galaxies away? Like, who gives a shit, right? There's so many problems that are going on this planet. We should use that money and learn about the problems that are affecting us directly. Okay, that second part is a great example of applied research, right? But most of the goals of NASA, most of the research that NASA conducts is basic. We study space largely because we want to know what the fuck is out there, right? We want to know where the universe came from. We want to know why we're here. We just want to know. Now, oftentimes, well, I will say too, because I'm a big fan of NASA, I'll say a lot of the research, even though it's quote unquote basic in nature, it often leads to applications here on Earth. Any one of you who's sleeping on a memory foam mattress at night, you can thank NASA for that. Those silver, like, thin mylar blankets that we get for if you run a marathon or if you were hypothermic in the woods, yeah, you can thank NASA for those as well. But the research they do is more of the we want to know kind of stuff. Applied research focuses more specifically on making applications to the world and contributing to solutions to problems that we have in the world. So there's definitely room for both types of research, particularly in a field like psychology and social psychology, extra particularly, right? Okay, so once we have, say, an idea for a study, or we have a question, we kind of need to refine that idea in a way that we're going to be able to test it, which means we have to be able to measure it somehow. And the thing that can make this somewhat difficult in psychology is that we often deal with very conceptual variables. We're interested in kind of abstract ideas, right? This is one of the reasons that we kind of get criticized as, a soft science in a sense. But I would say, no way. We're actually taking a look or doing research on more difficult subjects. Something like studying happiness. Well, what the hell is happiness? Happiness to me might be very different than what happiness is to you. There's no scale that I could put somebody on and measure how much happiness they have, right? There's no blood test to determine whether or not someone's in love or not. These are kind of abstract conceptual variables there, what we call constructs. So those abstract hypothetical types of variables we call constructs. So how the hell do we measure something like happiness? Go to PsychInfo or go to Google and type in, study about happiness. You're going to find tons of studies. People have been studying happiness. People study love. People study depression, right? Depression is a pretty hypothetical thing, construct as well, right? Because what how is a 5 on a depression scale for me the same as a 5 on a depression scale for you? Probably not, right? So we have to take these constructs, these ideas that exist out there, and we have to define them in a way that will let us manipulate them and measure them. And we call that an operational definition. So an operational definition states specifically how that conceptual variable will be manipulated or how it will be measured, right? So not all operational definitions are created equal. Some certainly are better than others. And that's where this idea of construct validity comes in. Construct validity is used to evaluate whether or not you're actually manipulating or measuring what you claim to be. Another way to think about construct validity is, how good is your operational definition? Is it really measuring that construct? So if I said, I'm going to define happiness as the number of times somebody laughs during a conversation, that's definitely an operational definition. I just took happiness, which is a construct, and I defined it in a way that I can measure systematically. But is laughing during a conversation necessarily a sign of happiness? Maybe, but it could be a sign of social awkwardness, social anxiety, fear. Like we laugh for a lot of different reasons. Not just because we're happy. Sometimes we do it because we feel obligated to do it, right? Especially if it's somebody we care about, or our boss or something we want to impress. So operational definitions are not always great, but construct validity is asking essentially, how well does your operational definition actually measure that construct? Okay, now I'm going to show you a video here. It's a small clip from Seinfeld, and hopefully y'all know Seinfeld. If not, it was a huge 90s sitcom TV show, extremely popular. And in this clip, just to set it up for you, one of the characters got caught having sex in the office, and he's getting fired for it. And I'll play the video, and you can see for yourself where we're going with this idea of defining a construct, right? So here we go. Maybe. There we go. There we go. This time. Jeez Louise, come on. Alright.
You had sex on your desk with the cleaning woman.
You never had sex in the office before?
No, I once made out with someone, but that's it.
Okay, all right, so you made out.
Well, that's not sex.
Kissing is sex.
Kissing is not sex.
George? Jerry?
Hey, did Jerry leave that drink next to Dick's on purpose?
No. George? Over here.
What are you doing here?
I'm taking the kid out to dinner. Cheer him up.
Hey, Jerry, when do you consider sex has taken place?
I would say, when the nipple makes its first appearance.
Okay, so clearly you can see it's a comedy, but this was in the 1990s. Something else happened in the 1990s that actually called into question what is sex, right? When has sex actually happened? And that was the impeachment of President Bill Clinton. So famously, Bill Clinton was impeached for lying about getting oral sex from Monica Lewinsky. And Bill Clinton got on TV and during his deposition as well. So he actually did commit a crime. He did lie under oath, right? But it was about sex and oral sex in particular. So people were kind of on the fence about this. Did he really lie? The problem is that where I see Bill Clinton made his big mistake was that he said, I did not have sexual relations with that woman, right? Ms. Lewinsky, he says. Whether you think oral sex is sex or not, and again, this was a debate, I think we would all agree that oral sex is sexual relations, right? It's sexual. So if he had just said, I did not have sex with her, yeah, he might have gotten off the hook from it. But the fact, because, is oral sex, does that count? Right? Are you no longer a virgin if you have oral sex? I don't know. Ask 5 different people, you might get 5 different answers to that. So even something as, what we think is something as basic as sex, has no clear definition. And in fact, if you're going to do research on sex and sexuality, you actually need to define what you mean by sex. Does oral count? Does anal count, right? Does it have to be the traditional heteronormative definition of insertive sex, right? You actually have to lay that out. You have to operationally define sex for, reasons that we just saw. Okay. So once we have our operational definitions for the variables we're interested in studying, we got to determine how we're going to measure these variables. The most popular way to measure variables in psychology, and particularly in social psychology, is through self-reports. So we give people a questionnaire or a survey to complete, to ask them what are their thoughts, their feelings, their desires. We could even ask them about their behaviors. There are some problems with self-reports. There are lots of benefits. It's very quick, very cheap. You get a lot of data from these self-reports. The problem is that they're not always entirely accurate, and sometimes they can be misleading, depending on how you ask a question. There's an entire science devoted to survey development and questionnaire development, because the way you ask a question, even the order in which you ask questions, can all affect how people respond to those questions. So as I said, they could be affected by the way in which questions are asked. And a part of that is that people can lie about their thoughts and their feelings and their behavior. And, some of the time they're lying because they're just assholes. They just want to mess with your data. But most of the time it's not. Humans tend to respond in what we call socially desirable ways. So if you were to give somebody a questionnaire about, how racist they are, let's say, people are likely to downplay those feelings that they have, unless they're, an unabashed Nazi or KKK member, white supremacist. Otherwise, most of us are going to try to present ourselves in a more socially desirable light. This is why some of the self-reports about the differences between men or males and females when it comes to lifetime sexual partners. Why we can't really trust it so much, because males will tend to overestimate the number of people they've slept with, and females will tend to underestimate the number of people they've slept with. Why? Well, because it's socially desirable for males to be studs, to go out there and, sleep with everyone they can. And, of course, if a woman did the same thing in our society, she would be considered promiscuous. So, there is a technique called the bogus pipeline. I haven't really seen this used so often. It's been, or recently rather, but it's like a fake lie detector test, that you can, it's not really, polygraphs are bullshit anyway. We'll see that later in this course. But the bogus pipeline is complete BS. It's not even hooked up to anything. But you basically want to kind of deceive the participant into answering honestly, by saying, if you lie, we'll know about it, right? There are some things that you can do in the survey itself to try to cut back on people responding in a socially desirable way, or at least to detect whether they're being honest or not. One easy way is to just ask the same question in lots of different ways and see if they're answering it consistently. But self-reports can be inaccurate for other reasons. Sometimes people just forget about their past thoughts or their past emotions or even their past behaviors, right? So our memories are really not that great, especially for mundane type of things. So we might not be getting, completely accurate results from these self-reports. Typically speaking, though, the benefits outweigh the negatives when it comes to using self-reports. Another way we can measure variables is through observations. So observations can be pretty simple, just counting the number of times somebody touches their face. Or they could be much more elaborate, where we actually have to define what it means for somebody to do this behavior that we're looking at, right? So I'll give you a quick example. In my methods course as an undergrad, we did an observational study just to see if people would be more or less likely to hold the door open for members of their own sex or the opposite sex. So one of the big things that we had to do was operationally define holding a door open. What does that actually mean, right? And you might say, what do you mean? That seems like it's pretty easy. It actually wasn't once you started to get into it. It's, well, did they have to see the person first? And did they actually have to stand there and hold the door open? How far away did the person have to be in order for it to count as a no door holds, right? What if they went through the door first and then they just held it open like this? Does that count? Like, should that be counted as something else? Do you literally just have to open the door, hold it open, and let the person go? You see where I'm going, right? It could start getting pretty elaborate in that regard. One of the issues that comes with observations, now observations tend to be better than self-reports, because if, just for example, if I ask you whether you floss every day, right, which you're supposed to, right, at least that's what the current dentists and dental association suggests, flossing every day. If we were to ask 100 people if they floss every day, we're probably going to get a higher number of people who say they floss every day than if we actually watched their bathroom nightly bathroom techniques, right? Or their routine, and we're actually paying attention to see if they're flossing every day. So you telling me you do something and me actually seeing you do it, which one's going to be more reliable? You telling me you're going to vote in the next election and me actually watching you go cast a ballot, which one of those is a more reliable measure? Well, of course, the observation. One of the problems, though, of course, is that we might disagree on whether, or we might disagree on what we actually saw. So, what do I mean by that? Well, there's something called the observation bias, meaning we often tend to see what we expect to see. So, if, for example, I think young people are just less likely to vote in general than, say, older people. That's a bias that I have walking in to observe the polls, right? So maybe I'll be less likely to notice when younger people are voting. That doesn't mean I'm going to miss all of them, but maybe I'll miss some, right? Because I'm not really looking for it. My brain's kind of focused on looking for the older people who are voting. So we're not immune to biases. Humans are biased creatures. That's just a fact. We are. It's much better to understand that you are, and to recognize that, and to try your best to correct for it. But trying your best is not good enough in science. So what we typically will do is have at least two people observe the same behavior, or observe the same variable, and then see how well those two people agree on what they saw. And we call that inter-rater reliability. So this helps to kind of control for observer bias. If you have two people who say they saw the same thing, that's much more reliable than just having one person say that they saw the same thing. And again, the same goes if we're talking about a courtroom. If you have two eyewitnesses say they saw you commit that crime, you're in trouble. I'm not even kidding. Eyewitness testimony is really powerful in a courtroom. Even though eyewitnesses are horrible evidence, usually really bad for a number of reasons. But if you get two, well, then now there's two people. That's pretty convincing stuff right there. Some other disadvantages to observational research is that it's often pretty time consuming, right? It takes a lot more resources, which means more people power, more money, more time. So you see less observational measurements in social psychological research. But of course it's still out there. You just see more self-reports. Some other ways of measuring variables is through various types of technology. So different types of technology can be used to measure cognitive and physiological responses. So we're seeing more and more of this popping up in social psychological research because the technology is getting cheaper. So even little liberal arts colleges like SUNY Oneonta can actually start affording things like eye tracking technology. So if you're not familiar with eye tracking technology, so kind of what the name suggests, right? It's this little camera there that's focused on where your pupils are. So you might be given a screen or a video to watch, and this machine is going to measure where your eyes are looking in this plane, or this in this image, right? So not just where your eyes are, but how long your eyes are staying focused on that. So that's one way of measuring, what's important to us or what we're interested in there. Brain imaging technology, that's still outside the budget of SUNY Oneonta. These are millions and millions of dollars. But brain imaging technology, something like positron emissions tomography or PT scan or fMRI scan, will allow you to see what parts of the brain are becoming more active during certain events or in response to a particular stimulus or situation. So those are some newer technologies that we kind of spoke about in the last chapter there. But these are also ways for us to measure variables, right? Okay, so research we already saw can be broken into, let's say, two major categories of basic research and applied research. But we could also break research into what we're going to call descriptive research. We'll see in a minute. Correlational research, experimental research as well, right? So let's start off with descriptive research. What falls into this kind of category? Well, the goal of descriptive research, not a surprise here, is to describe people and their thoughts and their feelings and their behaviors. We're not here to manipulate anything. We're here to watch, essentially. We're here to observe, largely, right? So, observational studies where you're not putting anybody into a situation that you're manipulating in any way. You're just observing. You're just watching, right? So just going to the mall, let's say. Not sure if it's even open yet. Haven't left that. I've barely left the house in a year. But let's say if it's open, you might just count to see how many people are wearing masks. And maybe as part of that observational study, you'll see if males or females are more likely to wear masks, or older and younger people are more likely to wear masks. What you're doing is just observing, you're collecting data, but you're not manipulating anything in any way. Archival studies is when we actually go back to data that has already been collected, or data that's already been produced, let's say. So a lot of people will analyze the census data, and there are a number of different big, large-scale, nationwide surveys that go out that people can go in and try to make sense of, and even do some correlational research, which we'll take a look at in a minute here. But an archival study might be going through newspapers for the past year and see how the media has changed in the way that they've spoken or described, let's say, the pandemic or some other type of event that happened. And surveys, another example of descriptive research. Now surveys can be an instrument that we use, like a self-report, but it can also be a let's say research method in and of itself. What do I mean by that? Well, if you get a call on your phone and they say, yeah, you wanted to take a complete a quick consumer survey, about such and such, or if you get a call on your phone and people want to ask you who you're going to vote for in the next election, those are all examples of survey research. For our purposes, some survey research might involve asking people what their opinions are about certain, say, social issues. Do you support same-sex marriage, for example? These are kind of public opinion polls, essentially. Now, with those types of survey studies, you need lots and lots of participants, And the way you select your participants has to be in a representative and ideally randomized manner. Okay, correlational research. Some people might say, yeah, this is descriptive research, essentially, but we put it in its own category because it does something a little more than just describe what's going on. It tells us something quantitative about the nature between two relationships, right? So it doesn't just describe, say, two variables, right? It's also going to tell us how strong, well, number one, is there a connection between those two variables, and how strong is that connection, and also in the nature of that connection, right? We'll see what I'm talking about in a minute here, right? So it measures the relationship between variables, and it can answer the questions about how similar or different those two variables are, and how well one variable might predict another variable. So correlational research makes use of a correlation coefficient, which we get from conducting statistical analyses. Typically, it's the Pearson's product moment correlation coefficient, and this measures the strength and direction of the relationship between two variables. And the number that we get is called R. That's just the statistical symbol for the Pearson correlation. And that value can range anywhere from +1 down to -1. And what's important to note is that the positive and the negative there only tell you the direction or the nature of the relationship. It doesn't tell you the strength. So when we're talking about a +1 correlation, that's just as strong as a -1 correlation. A -0.8 correlation is actually stronger than a +0.4 correlation. So the sign that exists in front of these values only tells us the direction. When we want to know about the strength, we're concerned about the absolute value there, which is that bullet point I just talked about this. So absolute values indicate strength, positive or negative indicates the direction. So let's do a quick example here. This is a really blurry video. Now that we're all in high def here, I'll get a little better. Okay, so this is just a little video that I put together of a scatter plot. So what does the scatter plot do? Well, it takes the data that we have for two variables, in this case, the number of hours a student studied and the grade that they got on the exam. So in this example, we have 6 participants or 6 students, and I have 2 data points for each of them. So this video is going to go through each one of these students, and it's going to go on the x-axis here, which is the number of hours that they studied. And for participant 1, they studied for 2 hours. And then it's going to go up on the y-axis, which is their exam grade. And we're going to go to, in this case, they got a 70. So this data point right here represents this participant and their values on each of those variables. So I'll play this video and you can see how this scatter plot forms. Okay. Oops. Get out of there. I gotta put an ad in there. Okay, so we went through each of these. We got our scatter plot there. And then you saw this line go through the data. This is what we call the line of best fit. So the line of best fit is also called the regression line. If we did it properly, there's an actual equation and math behind fitting that line as a regression line or as a line of best fit. But basically, if you were given just one straight line to represent all of the data, where would you place that line? That's essentially what this line is doing. So we could take a look at these type of lines somehow and understand that they're representing a whole scatter plot around it. Now in this case we have an R, or a correlation, of roughly 0.7, roughly positive 0.7, right? And we'll see what that means in a minute here. But you can see again that the line has to represent all this data. So it's doing a better job at representing some data than others, right? It's a little closer to this one than it is to this data point. A little closer here, here, there. It's doing a really bad job at predicting this data point down here. But that data point has a special name. We call that an outlier. It's a data point that's not fitting in with the rest of our data. And it's actually what's probably pulling the strength of this correlation down quite a bit. But I'll tell you just, to give you the heads up, a 0.7 correlation is considered a strong or moderate to strong correlation. And that should be no surprise, right? That there's a strong correlation between the number of hours that you study for an exam and the test or the grade that you get on that exam. Okay, now here's an example of some different correlations that we might experience. That first example we saw was a positive 0.7. So a positive correlation means that as we go up on the x-axis, we're also going up, or we're also increasing on the y-axis, right? So in this case, a positive correlation, both variables are going to go up. So as I go from few to many on the x-axis, I'm going to go from cold to hot on the y-axis. And a straight line, if you ever just see a straight line like that with no data surrounding it, that means it's a perfect positive 1 correlation, right? It means there's a perfect correlation between those two variables. With a negative correlation, it could be just as strong, but what it means is that as we go up on one axis, so as we are increasing on x, we're actually decreasing on y. So the relationship is flipped, essentially, right? So when we see a negative correlation, we know that as one variable increases, the other variable is decreasing. And again, if we only had a straight line there, and we didn't have all these data points around it, we would assume that that is a perfect negative correlation, or -1 correlation. It's just as strong as the positive 1 correlation. It's just in a different direction. And then, of course, we have a correlation of 0, an R of 0, right? Which means there's nothing going on right there. So when do we get a correlation of 0? Pretty much never, right? We'll see why in a little bit, but it's really rare to get a perfect correlation of any of these three. To get a perfect positive correlation, a perfect negative correlation, or a complete 0 correlation. Why? Well, our measures have error built into them. Statistical noise, right? Where there's always going to be something in there that's going to make measuring something 100% damn near impossible. An example of this, if we were meeting in person, what I would do is pass around these little paper rulers. And then I would ask you to measure your index finger, right? And write it down. And then ask you to measure it again and write it down. And ask you to measure it again and write it down. And each measurement is going to be, chances are, right? Each measurement is going to be slightly different from one another. So to get perfect correlations of positive one over here, or negative one over here, or 0, yeah, you don't really find that because of statistical noise. So what are some advantages of a correlational study? Well, it allows us to study the associations of naturally occurring variables that we can't study in a lab because it's either impossible to manipulate or it would be really unethical for us to manipulate. So something that occurs naturally in nature, that, I mean, we can study with correlational methods, say the effects of being struck by lightning, but it'd be really hard. I mean, we could have someone outside holding a big pole in a thunderstorm. That does not mean that they will necessarily be hit by lightning. Certainly increases their chance, which would be highly unethical to do, right? So, number one, we're dealing with, we can't really manipulate the weather or where lightning will strike. We can kind of manipulate, means there's lightning rods. You can kind of make lightning want to go into a certain direction. But of course, that would be incredibly unethical for us to do such a thing. Another advantage is that it offers freedom in settings in which variables are measured, meaning we could look at stuff outside of the laboratory. So we can go look at stuff in the real world, right? So that's kind of cool. One major disadvantage of correlational research is that just because you have two variables that are correlated, it does not mean that one is causing the other one to happen. In other words, correlation does not equal causation. So that's a big one. That's a really big one. And that's something I'm sure you've heard before, and something that'll kind of get drilled into your head. Because it's a major logical fallacy, right? People, I'm sure we get in arguments with people all the time saying, well, this has to be true because look at, they can't stay out of jail, or they can't do this, or they can't do that. And what are they doing? They're saying there's causation there when they're talking about a correlation. So you might say, well, Brown, so what's the big deal? What's wrong with that? Well, a couple of things, right? Because number one, we don't know which direction that correlation is going in. If there is some type of causal relationship, we don't know which variable is causing the other one, right? So if we did a correlational study on whether playing violent video games leads to aggression, we can't say yes it does or no it doesn't based on a correlational study, right? If there's zero correlation there, then we could probably safely say that it doesn't lead to aggression. But what if we do find a correlation? What if we say, hey, these two variables are highly correlated, right? So maybe we should ban violent video games. And I would say, no, maybe we shouldn't, right? Maybe we should take some more methods and stats classes. No, I probably would say, no, maybe we should do an experiment. Lots of them. Because one possible explanation is that video games might be causing aggression, but maybe aggression is causing people to play these violent video games. If you're just naturally more aggressive, maybe you'll be drawn to playing violent video games, right? So the direction could go either way. We also run into what's known as the third variable problem. Third variable problem is that there might be some other variable out there that is causing both of these things. Some other variable that we didn't look at. Some other variable that we might not even know about, right? So in this example, we have variable C, which is family trouble. So maybe some family dysfunction causes both more aggression in children and causes them to seek out these violent video games as maybe an escape from that dysfunctional family atmosphere, right? And finally, not mentioned on here, we have just coincidence, right? Just chance. Maybe there's just a coincidence happening. So, every year we see this correlation that exists between people going to the beach, or people eating ice cream cones and shark attacks, right? Well, maybe it's just a coincidence because it's summertime, right? So you would imagine more people are out on the beach and it's warmer, so more people might be eating ice cream. Maybe it's just by chance that we would find a connection. Or maybe summer is acting kind of like a third variable in that situation, that it's causing both. Summer is causing more shark attacks, and because more people are going to the beach and going swimming, and it's causing us to eat more ice cream because it's hot, right? Okay, I promised myself I would not do 2 30-hour lectures, so what I'm going to do is break right now, and then I'll start a part 2 for this lecture. That way you can watch one today, watch one on Thursday, like we would do if we were in class meeting in person. Okay, so when we return for part 2, we'll start with experimental designs. I will see you then in a bit. Take care.